An industrial engineer can do a lot of different things. And the reason they can do a lot of different things is because what they learn in school is basically how to take people in an organization or anyone working in a manufacturing environment or a certain type of process and improve their productivity. Oftentimes they're referred to as efficiency experts. It's kind of a misnomer, but they use engineering methods, and you will see that in order to go in and problem solve to help a, um, a work environment work better, work more efficiently, that idea can be applied to almost anything we do in life. And so an industrial engineer can work in a lot of different industries, a lot of different places, although it's first started out as a time and motion study type of discipline that was dedicated solely to manufacturing. But today that's not true. Industrial engineers can work in many, many different places. And ultimately, because of the skills that they acquire in working in different organizations, they tend to also utilize those skills in order to improve and help themselves go up in the career path and the career ladder. So, what does it take to become an industrial engineer? And I'll speak for myself. I won't speak for everyone. But it's a engineering. Taking engineering in school, any type of engineering, is a more what I would consider a much more straight and narrow path of selection of courses. It's much more defined than maybe some other disciplines, maybe perhaps in the liberal arts degrees. You typically take all of the sciences, all of the different math. You have to potentially like math and science. But I think the reason I liked industrial engineering and what I would consider about industrial engineering different than the other engineering disciplines is it's not quite as funneled and narrow a path as some other, like a chemical chemistry major or a civil engineering major. Industrial engineering applies also a certain level of creativity because it does involve improvement studies, problem solving, and therefore, in order to problem solve, you generally have to apply some level of creativity. And that's the reason I chose to go into because I like math and science, but I wasn't solely a right brain person, so I was happy with the combination that it allowed me, and also as a discipline even though I like the math and sciences, it allowed me to choose different places that I can apply the skill set that I learned. What I would say industrial engineers like and dislike, and again, I have to speak for myself because I can't speak for others, is the classic learnings of industrial engineering is the initial aspect and application is time and motion studies. Time and motion studies is from the very beginnings of industrial engineering, where you can take a process such as a repetitive process, such as ticketing socks in a warehouse, or any sort of manufacturing process where people are doing the same function. And you measure, you look at productivity and break down all of those processes so that you have measurements of time within a day that they can maintain a certain pace of work with breaks and so forth and have a measured level of productivity throughout the day. When you add all that up together times hundreds of employees and you improve a process here and there, it can add up to quite a bit of savings for a company. That can get kind of monotonous after a while. What I do like about, however, industrial engineering is that you have to apply a level of creativity. You have to problem solve. You have to go into situations that you don't know anything about. You have to learn about it and you have to improve upon it. And I find that skill set is very applicable across industries, across different functions. And ultimately, if you look at even famous engineers, famous industrial engineers today, you can see that those skill sets can be applicable in any sort of industry. Lee Iacocca, the head of Chrysler, DeLorean, who invented the famous car, Tim Cook, the CEO of Apple, all industrial engineering majors. And so, not saying that we will all become those positions, but those are examples, quite good examples of where industrial engineering can lead. I got my first industrial engineering job through school. Companies came to our school. We interviewed. If they liked us, we went on a couple of other interviews, went to their respective organizations and interviewed with other personnel. And I was very lucky to obtain a job quite soon. I'll speak to just throughout my career of getting other jobs in other organizations, and what I found is that obtaining an industrial engineering job, or any job for that matter, the social capital, the aspect of differentiating yourself, showing results of what you've done, your experience, being able to talk to all of that is quite important. Not just showing up for work, but to show that you've actually contributed. But just as important is also the ability to maintain contacts, speak to connections and people that and friends, frankly, that you've met throughout your career, or in school, or with teachers. Show that you are just a step above from the standpoint of wanting to add that little extra something, and then add that personal piece where you have good communication skills, are friendly, are amicable, you get along with others. That combination, I think, can be overlooked and quite powerful. One career project that comes to mind is when I was working for the Port Authority in New York and New Jersey. I worked in a division, an engineering division at the Port Authority that did projects for the entire company. The area we were responsible for were the tunnels, bridges, and tolls. And what we did is we were the first state in the entire country to introduce E-ZPass. What we had to do, though, was, because New York City is a different animal than just putting E-ZPass on a highway where traffic flows through and there's no pre or post toll lane traffic. New York, you can't just take cars and dump them into the tunnels or into New York City. It would create more problems and tensions between the two states. So we had to do an inordinate amount of traffic studies, time studies, all throughout the day, different times of the year, seasonal impacts, and understand how many lanes should get E-ZPass, which lanes should get E-ZPass, with the ultimate goal of allowing a smooth flow of traffic into New York City while saving the consumer that uses E-ZPass money due to ease of use and auto billing. A career story I'd like to share is when I was working at Lord & Taylor. I was hired at Lord & Taylor particularly because they wanted to introduce industrial engineering to the company. I was working for the Senior Vice President of Operations, and he had this notion that the back store functions where they did the shipping, where the ticketing was done for all of the clothing at their distribution centers, all needed some process improvements. And the project we worked on at the time was not what I say the most terribly interesting, but my point of this story is I want to show how little things can make huge impacts when one is working. So you never should just overlook or assume when you're doing any kinds of work. All we did was go in and do a time motion study of the people that were ticketing at in the distribution centers. Long story short, if you took what we did and throughout their processes and how we were able to improve even a 10% improvement on an individual working during the workday, and you take that and you multiply it by several hundred employees, and you multiply that by 50 different stores, we ended up saving millions of dollars for the company. And so that was the exciting piece, even though what we did was repetitive and not so interesting, but you have to always focus on the bigger picture many times.